All right, thank you very much. Welcome back to today's class. And today we are going to be talking about something that is very important for solar systems installation and design. In our previous class, we talked about how to size breakers for solar systems. And I promised you that we are going to also see how we can connect these breakers together, the AC breakers, DC breakers, surge protecting devices, into a combiner bus or a solar protection bus or a solar protection kit. And that is exactly what we're going to do in today's class. Now you can see that I've already given you an outline of how these protection kits or these protection devices are being installed. Now from the DC side, the AC side, and also the inverter and the battery. So I'm going to quickly explain all of these block diagrams. Then from here, we move into how to practically connect the components in a solar protection kit inside a combiner box using cables, screwdrivers, and so on and so forth. In a full solar system, different kinds of current flow. We have DC current from the solar panels to the controller up to the battery. Even DC current flows from the battery to the inverter. Then the inverter converts the voltage from the batteries to AC voltage or current. Then also, when you charge the inverter or the battery with grid supply, AC voltage or current also flows into the inverter as input to the inverter to charge the batteries. Different kinds of current flows through a solar system, and so we need to divide it into different parts. We have the DC protection, we have the AC protection, then we have the inverter slash the battery protection. Then for the DC protection, what do you do? First of all, you have your panels, like you all know. From the panel, we have the DC breaker. From the panels, you are supposed to connect a DC breaker. From the DC breaker, you loop in your surge protective device, a DC surge protective device or DC SPD. Then from the DC SPD, you connect to a charge controller. That's everything you need to know about the protection for the DC side. If all these things are intact, then your solar systems for the DC side is completely secure and safe. You need to understand that the DC surge, the DC SPD has an earth terminal where when you connect inputs, positive and negative from DC breaker, you have the earth terminal where you have to take to the ground in order for excess voltage or spikes or surges to flow through this terminal to the ground. Then we have the controller, charge controller. Then for the AC side, we have the grid and generator inputs. You normally connect inputs from your grid or from your generator to the inverter to be able to charge as an extra charging source. In case of days where there isn't enough sun, you can have an extra charging source. So the grid and gen inputs can connect to an AC breaker. From the AC breaker, similarly, an AC SPD or AC surge protective device. There's AC SPD. So then from the AC SPD to AVS, automatic voltage switcher, or some persons call it voltage protector, voltage and current protector, VA protector. Then from the VA protector to the inverter's AC input, this that is connected. Similarly, the AC SPD has an earth terminal where when you connect the AC breaker, the plus and minus, you loop in to the AC SPD, then an earth terminal is supposed to go to the ground for proper connection. Then from there, we go to the inverter and the battery. Between the inverter and the battery, we have a breaker, MCCB, or the battery breaker. Then from the breaker, connect to the inverter. From the inverter, in most cases, some persons also use AC breaker to connect the output of the inverter to an AVS as well, output AVS. Then from the AVS, also to the DB, where you can connect your entire load or you do separation and all that. Some persons keep these two components. They go ahead and connect the inverter straight to the DB. Some persons connect just the breaker to the DB. But in solar systems protection, there's no such term as overprotection. So if you need to add everything, if you have the means, just try to add the AC breaker, the output breaker from the inverter to the DB or even to the AVS, then also to the DB. Why is it important to connect an AVS? Just in case the voltage, you don't want the load that you consume to exceed a particular power. So you can actually set the amount of power you want the inverter to supply to the load at a particular time. So if it exceeds that amount of power or voltage or current, the AVS will trip off. It not allow the inverter to send output to the DB. It's just a protective measure. You get it? So, and again, the inverter has an earth terminal. So you also earth the inverter. And it's very important for you to know that all these separate earthings, we have earth DC surge, we have AC surge, we have earth, then we have inverter, we have earth. You are not meant to connect them together at the point where you connect your components on the combiner box. For instance, you cannot just connect a small wire from here, maybe, okay, let's just do dotted connection from here to here. Then you connect this from here to here. Then you now use a bigger wire to connect to the ground. It's not a good practice. Now, the thing is, all these earth wires, they will end up on the ground eventually, but you need to make sure they are at the same ground potential. So you need an earth bar, a big earth bar, where you take all these earth wires down to the earth bar. For instance, the DC, you can connect DC here to this bar, then the AC to this, then the inverter to this. Then from here, everything can link to the ground with a single earth rod or earth cable and all that. So it is properly earthed in this manner. If you connect this earth to this earth and to this earth, if there are potential differences, current can flow from here to here or from within the system, and it can cause damage to the whole protection kits and all that. So to ensure that the earthing is very, very okay and very effective, you need to make sure you use an earth bar, a single earth bar at the ground level. Then you connect a wire from each of the SPDs and all the parts where you need to earth. Take it down to this bar so that they'll be at the same earth potential. Then from there, you can take it down to the ground. But if you connect it separately, connect this to this, that to that, the resistance between here and here is can be more or less than the resistance between here and here. So when we have different resistances, we have different potentials, this can give room for currents to flow around, and you have leakage currents all around. And when the earth resistance is not as effective as the resistance between each of these points you connect together, then the earthing will not be effective. It's going to clamp back to the device and affect some systems in your protection setup. So you need to make sure everything goes to an earth bar close to the ground so that the resistance will be almost equal. Then everything goes to the earth and the earthing is effective. So from here, from this point onward, I'm going to show you the combiner box. I'll show you the different components and how to connect them. I'll practically use my screwdrivers and pliers and everything to connect it so that you see how it is done. So, and again, make sure you connect where you are watching the video from so that we're able to know how far this solar movement has gone around the globe. Thank you very much. All right, apparently this is how the enclosure box is. We are going to just do a demonstration on how to connect a basic protection setup for an average solar system. Most solar systems, you might not actually need to embed all of the protecting devices that I showed you earlier, like the AC and DC breakers, AC and DC surges, RTB breakers, and so on and so forth. We had about up to 8 or 9 protective breakers I showed you on the board. And now, so for a simple setup, basically you're going to be needing this. Is a surge protective device, as you can see from scale. Normally, they don't conduct current, but when there's a sudden voltage spike, it diverts that surge to the earth through the grounding terminal right here. So you can see the ratings. You can see this UC 500 volts DC, the maximum voltage that the SPD can handle. Then we have the IMAX, that's the maximum surge current it can divert, 40 kiloamps. Then we have the nominal discharge current, which is 20 kiloamps. Then we have the voltage level that may appear across the SPD during a surge. So we have all this. For AC surge protective device, you see something like 230 volts at this point, 240 volts. but this is a DC. Normally for most hybrid inverters that have maximum input voltage as 500 volts, this one can work well. So basically we have this connected. Now this is how it is placed on the enclosure box with a DIN rail. So you open this one like this, take it up, so it's going to fit in like this, then you lock. So like this, it's not going to pull out. Then from there we have the DC breaker. So this is not a DC breaker, I just need to use this to explain. Just assume this is the DC breaker. This is how a DC breaker is. So we have 2 inputs, 2 outputs. Put it there. This is a double pole breaker. We have single pole breakers as well, but for solar systems, it is best to use double pole breakers. So this, the DC breaker. This one is for the DC side. Then for the AC side, we have the AC breaker right here. Also the same way, open, then fix, then lock. From the AC breaker, we have the AC voltage and current protector right here. So you also lock, open, then we fix it in, you lock. Okay, so this is how it is. Normally you try to separate the DC side from the AC side. In some cases, you might need to use more than one of these boxes. If you have a lot of devices to connect all the AC to one box, then all the DC to one box. But you can as well use one box to connect all of the devices. For the AC side, you can add the AC output breaker. Let me use this to present the output breaker for the AC. This is an AC breaker, 100 amps. So you just put it here. The 3-pole breaker. So you can connect live, neutral, and earth. Then this is the output voltage and current protector for the inverter. So you can as well add this to make the setup complete. But basically, most setups you will only have 1, 2, 3, 4. With these 4, you are good to go basically. But if you want to add additional protection, you can go ahead and add this and as well this. So I'm going to show you how to connect all these devices. Very simple and very easy, straightforward. First of all, you connect the input from your solar panel is going to go into the DC breaker. Then from the DC breaker, you're going to loop it into the surge protective device or the DC surge. The same way you connect your AC surge. We don't have AC surge right here, but if you have AC surge, the same way you connect on the breaker, you loop to the AC surge. Then the earth terminal, you're going to bring them all to the earth bar. Okay, let's connect. First of all, just take a wire, use DC cables for the DC side. Then for the AC side, use AC cables. Just try to peel it off. Okay, so this is the cable. Now, if you can watch closely, you see that the positive and negative for the SPD is indicated. This is DC plus, this is DC minus, is polarized. But most breakers, most DC breakers, you don't find this written. So you are going to choose by yourself which of them you want to be the positive and negative. So if you want this one to still follow the same convention with this, let's just say these still are positive and these are negative. Now for positive, you are going to use blue cable because most DC cables out there, we have the color code as blue and black. Blue is positive and black is negative. So make sure you are consistent in all your connections. Then for now, we are going to just connect like this. Connect positive. Positive is connected. Connect it to positive of the breaker. That's the input. Then negative connects to negative. It's best practice for you to use ferrules for your connections because this is a demonstration. I don't only have ferrules at the moment, so in a separate video I can also do a video on how to use ferrules for your connection. So put this one here, negative, then connect to negative of this DC breaker. Okay. Okay, and ensure your connection is tight. Get? All right. Okay, so that's for that. That's for the DC breaker and the DC surge protective device. Then now go straight to the AC breaker. For the AC breaker, you're going to use AC cable. Use an AC cable. Depending on the size of your system, that will enable you to know the size of cable that you should use. For this system, for DC side, most times we use 6 mm or 10 mm cable to do the connection for the breakers and the surges. Then for AC, depending on your system, if it's a 5 kV or a 10 kV system, ensure you use nothing less than 6 mm. In most cases, sometimes you can use 10 mm flex, AC cable flex cable. It's best practice for you to use flex cable because the connection is more secure when you use flex than single strand. This is what I mean by flex cable. You have a lot of strands connected together. But why single strands, most times you may be having partial contact. So for your AC cable, also connect. If you have AC surge, the same thing, the same connection, you loop your AC breaker to your AC surge. It's just looping and looping, that's all. Okay? Because it has just one side you need to connect. There's no output. The only output is the earth. Then let's assume this is our AC surge protective device. So you bring it closer to this place. Let's assume it's our AC surge. Or just take it closer to this side as well. Okay. Now you measure this plus, this minus, this plus, this minus. So you measure like this and cut with your plier. Open. Okay. So connect. Use these cables. Okay. That's for positive. And also connect negative with a black cable. Connect negative. For demonstration purposes, let's just use this one. Connect. Negative. Also connect the negative. Okay. Now it means these are 8 for the AC surge, 8 for DC surge, 8 for AC surge. Assume that this one is non-existent. So these are 8 for the AC surge. So we can assume these are 8 bar. We'll connect all of these 8 terminals to the 8 bar here. So they can be at the same potential. Okay. Now, this where it gets tricky. How do we not connect to this device here? This is the voltage protector. Now, the output of this breaker goes into the input of this voltage protector or AVS. This is the output of the breaker. You are connecting your grid input to this point while it loops to the surge protective device, the AC surge. Then from this same point, it comes here. When you switch it on, the output comes to this point. So you're going to connect the output from here to the input of this one. Then from the input of this one, you get output here. So when the output comes from here and it goes to the inverter's input, that's how the circuit is complete at that point. Now, ensure there's space here so that you can pass the wire through this space to connect here. The same thing, this word, this word, this is negative, this is negative. So you connect positive from here down to this place, this is positive. Now, because it's AC, it doesn't have polarity. You can connect, any one can be negative, this one can be positive. You can do it vice versa. So let me just follow the same convention. The left negative positive and the right negative. So I'll connect this one positive to this side. So let's see, use an AC cable, red. Polarity is very important. Make sure you use the right color code for your cables. Open the cable. So you're connecting from here. So you go like this. So you bend it because it's going to go like this. Okay, from here. So when it gets here, you bend it again. You bend it. So it's going to go like this up to this point. So bend it here again at this point. Then you get the results you want. Cut. Okay, so connect now. This positive. You can see that it's very simple and easy, straightforward. Just inputs and outputs, nothing more. Then do the same thing for the negative. Ensure it's tight. And okay, so you can see we're getting there gradually. We're getting there. Now, this output is what you are going to connect to the input of the inverter to ensure that your grid or your NEPA charges the batteries through the inverter's charger. Okay, then why this output is what you're going to connect to your charge controller. Now you connect the input from your panels up here, then it loops to this surge protective device. Then also you connect the inputs from your grid or your generator up here, then it loops to the AC surge protective device. Then the output from the grid goes to the AVS. Then the AVS corrects the current and the voltage, checks the current and voltage to make sure it is in the right range. Then it sends the output down to the input of the inverter to protect the inverter from high voltage and high current. Then again, your inverter's output connects live, neutral, and earth from the inverter in, then the output from here goes to your DB. So this is the entire connection, this is the entire setup. Then for your earthing, connect the earth from here and from here. You can connect it to use a thick cable, make sure the cable is of the same length, the same size. Then you drag it to the earth bar close to the ground where you're going to mount you're going to dig your earth rod or the earth pit. So you connect a bar, an earth bar there, a bus bar, connect everything together on the metal, then put the earth rod on the ground. Then make sure that place the resistance is low so that current can flow through into that place from any point, whether from the AC surge or the DC surge or from the inverter, wherever the surge current or wherever the leakage current or fault current is coming from, can flow to the earth terminal directly. So let me take it to a small inverter setup for you to really understand how you can incorporate this protective box in that setup. Then we see what can happen. Then I'll also show you how to set this device because a lot of persons don't know how to set this device. I'll show you that, so and that'll be it for the video. Before I show you that, I need to mention something. Now, when it comes to the connection between this AC breaker and this AVS, a lot of persons prefer to connect the input to the AVS first before the AC breaker. But the reason I don't like that connection is that when you connect the AVS first, the advantage of doing that is that the AVS will always be on, and you can use that to know exactly whether there's light or not. So that's the advantage of doing that. But in a situation whereby the AVS trips off and is not able to recover or to reset and start to charge the battery again, it just remain like that. The only thing you need to do is for you to go and disconnect it from the source. Then you connect it back. But when you put the breaker before the AVS, if the AVS most times these AVS, when they sense high voltage, even if the voltage has been corrected, it will take sometimes more than 3 hours before it resets, because sometimes the AVS might not be working well. So all you need to do at that point is to switch off the breaker and switch it on. So when you switch off the breaker, the input to the AVS is going to go off totally. So when you switch it on, it's going to reset. So when it resets, it starts charging. But if this one comes first before this breaker, if there's an over voltage or under voltage, and even if the voltage has dropped and it's not able to reset by the settings you did, it's just going to remain like that. So most times you have light and discover that nothing charged the inverter or the battery when there was light. So to avoid that, you need to connect the breaker first before you connect the AVS, to avoid all of that disappointment. Okay, so I think you understand what is going on right here. So this is how to connect it, nothing more, nothing less. Okay, so and again, then we have the battery breaker. It's just straightforward. From the inverter to the battery, you connect the breaker. Use a different box for that. You cannot put that battery breaker on this box. These are the only breakers that can fit into this box. When the breakers are too many, you can decide to split it. Get AC breaker or get this. Or some breakers, they have two compartments up and down. We have 4 ways up, 4 ways down. You can connect the breakers on top for the AC, then the breakers at the bottom for the DC. And as well, you can also do it like this if you prefer this method. Okay, so when you do it like this, you just have to lock the breaker box and put the screwdrivers to lock it. Then knock out these holes where you connect the input and the output. These holes connect the input to this from the solar panel. Then connect the input from the grid to this for the charging. Then you connect the output from this to the inverter, output from here to the charge controller, output from here to the DB. So that's it. Okay, let's check the basic settings of this AVS. Now what you do, if you want to set this AVS, first of all, you go over to this M, press this M button. Now this is program 1. Program 1 is power on delay. So how many seconds do you want it to delay before it powers on? So this is currently at 5 seconds. You can increase it to up to 999 seconds. So if I want it to delay for 1 minute before it powers on, take it to 60 seconds. Okay. Then program 2 is recovery delay. Recovery delay is how long do you want it to hold or to delay before it comes back on when it senses an under voltage or over voltage. So let's leave it at 1 minute as well. That's 60 seconds. So you take it to 60 seconds. Then program 3 is the over voltage value. So this is the value for the over voltage. So we're going to reduce it. It's very high. So I want it to shut down at 240 volts. So when it exceeds 240 volts, it's going to shut down and wait for 60 seconds. If at 60 seconds it has not dropped, it will still remain on shutdown. So 60 over voltage 240. Then this program 4. Program 4 is over voltage value. So this at this value, if it drops down to this value, let me take it, reduce it to 235. So at 2, okay, let's say at 235, 235, or let's say 238, is going to reset and start to supply power. Program 5 is on the voltage value. So let's leave it at 180. So anything below 180, or let's say 175, you have to check your inverter to know the right voltage to use. 175, then the recovery value, it's 180. When it gets to 180, or let's say 178, it's going to recover and start to supply power. So 178. Okay, program 9 is overcurrent. 63 amps is very, very high. So we're going to reduce it to 30 amps. I'm using a 30 amps breaker most times, so you reduce to the size of your breaker. So let's take it to 30 amps. So when you multiply 30 by the voltage, you get the power, maximum power that you can pull out of this device. that this device will allow you to pull from your inverter rather. So let's leave it at, or let's say 25 amps. Okay, that's 25 amps. So which other program do we need to set? I think the rest is not actually needed. So we have our voltage protector working on active. So right now the value is 206 volts. So when I switch it on and off, it's not going to come on immediately until 60 seconds, 1 minute time. So it's going to count down from 60 down to 1. Power up time 57, 56, 55 is delay mode. So this thing is very important both for your input and for your output. If you have the mains, just try to make sure everything is complete. Your voltage protectors, both input and output, surge protectors, input DC and AC, then your input breakers, output breakers, then solar DC breaker, then your battery breaker, and make sure everything is well earthed to the ground using an earth bar. And also, if you have the means, try to install thunder arrestors. And with that, your inverter system is safe from any kind of spikes, surges, and high voltage or low voltage that I want to affect the inverter. So that's all you need to know. This is a simple setup where you can apply this connection. Now you can see that from here, this is the cable that is coming from the panel, solar panels. Is directly connected to the input here, panel input. But normally it's supposed to come straight to the input of this. You loop it in positive and negative. So when you loop it in here, it also loops to this such protective device. Then the earthing is constant. Then the output here is what goes into this inputs here. So this one is actually supposed to come from here. So from here to this input, you have the battery connection from here to the battery. Then there's supposed to be a breaker here for the battery. This is my setup, don't mind me. Solar installers we are very stubborn. We don't like to do these things, but we only do it for customers. Okay, so it goes to the battery breaker here. Then again, this is the input, AC input. Normally, this is the AC input. So you connect this one, first of all, to this part where it loops to the AC surge. Then again, the output connected to this AVS. Then the AVS, the output of the AVS goes to the inverter, but here is going to the inverter directly. Then the output of the inverter, which is this wire, to this changeover. Before it gets to this changeover, you're supposed to connect it to a breaker fix, whether it's left or neutral, or sometimes left or neutral. Then the output goes to the changeover where you can switch. So that's all for that. So this is solar protective kit. And I know you've learned a lot from this video. So please make sure you click on the subscribe button and like and share and put your comments in there. If you have questions, ask your questions. I'm there to answer your questions and everything. So just try to support me on my channel and let's go together and learn together. And I'll see everyone at the top and I'll see you in the next video. Thank you very much. Bye. Have a blessed day.